Good evening. My name's David Johnson. I'm a software engineer at Goonhilly Earth Station, and I'm also the Honorary Secretary of AMSAT UK, amongst other hobbies, which I'll go into later. My background, I've been doing radio since about 1972. Not long afterwards, I got involved in space as a hobby. I've been doing software engineering since about 1980. So I cut my teeth on mainframes. I've been doing mechatronics, in other words, robotics and computers, since about 1982. I then moved into being a chip designer in about 1986, doing fairly small scale devices. Then moved on to larger scale computer systems in about 1990. Then space systems development in about 1995. So I've done a fairly checkered history of in my career. I'm now semi-retired, and I'm bringing all these skills together for Goonhilly Earth Station, for whom I've worked now for 3.5 years. 3 years. Goonhilly is down in the very southwest of the UK, and that's where home is, up in Birmingham. So about once every 3 months, I do the 260-mile trip down to Goonhilly. I was there last weekend. Sorry, I was there last week for 3 days. I'll talk more about that later. I've got a couple of demos that hopefully will work later on in the presentation. The image on the right-hand side is the site at Goonhilly. It was an old British Telecom site. The largest antenna called Arthur, which is just hidden behind the icon there, is the system that used the Telstar satellite for the first transatlantic broadcast of TV. It's now a scheduled monument, so we have to look after it. I'll show you more about our antennas in the next couple of slides. What I do at Goonhilly, this is GHY6. All these major antennas are identified by a number. They also have a nickname. This one is Merlin. Merlin is about 1970 something vintage. It's a 93 meter in diameter dish, used for deep space communications. And that's what I do. I spend all my time writing software for deep space comms. So it's the moon, it's Mars, and we do a bit of Jupiter work with the Juno satellite. Our main work is for the European Space Agency. So we have a live feed from Mars Express every day. There is a solar satellite called Integral. That's actually measuring a lot of the Earth's magnetic field as well. Before Gaia went offline, we had regular contact with Gaia and with Cluster 2. We also did a lot of work with Artemis, with the precursor mission around the moon. But we're going to be supporting Artemis in whatever form it takes, given NASA's proclivity for winding projects up. But we're expecting to be working with Artemis for at least the next 3 years. We've also done work with lunar landers, with Chandrayaan-3, which was very successful. Hakuto-R, which fell over. Intuitive Machines, which fell over. We're also doing work with another company that's going to be heading for the moon in the next 6 months or so. But we're looking at working with Intuitive Machines for M2. They've done quite a lot of redesign to make it stick this time, all being well. Challenges we have at Goonhilly. We are pointing at a very, very fixed point a point in space that is moving relative to the Earth. The moon's a challenge because it's moving quite quickly. We've got things like the space telescopes out at L2, so we've got to track them very accurately. Our precision for pointing is 7/10 of a degree when we're talking out towards Mars, and even tighter when we're looking at Jupiter. So we've got to know where we are, what the Earth's rotation is, what the diameter of the Earth is, where the fixed point of Goonhilly is, where the satellite is at any point in time. And it's a three body system usually, because it's the sun, moon, and where the satellite is. So there's quite a lot of complex math involved. We get a rough prediction from ESA, within a few kilometers of where they expect the satellite to be, or the spacecraft. We then have to do ranging to actually determine what the Doppler correction is going to be, to actually get to to actually communicate with the asset. I'll call it an asset now from now on. So it's quite a challenge we have to do in real time with that for our operators. We've also got other large dishes on site. GHY3 is now used for radio astronomy. It's also used for situation awareness. Space situation awareness. I've got to get that right. In other words, there's a military problem now where other agencies may be sneaking up on your particularly geostationary satellite. So we want to check what's nearby. Are there any dark satellites creeping up on us? So space situation awareness is one of the things that we're looking at. The item on the right is at the prime focus of GHY2. The problem with microwave and X-band, particularly Ku band, at many gigahertz, is that the dish can see itself in terms of infrared radiation. So we have to keep everything rather cool. So this is a cryostat, which is actually at the prime focus of GHY6, and we run it at 7 Kelvin. So the sensors can't see the dish itself. Quite a challenge. Quite a few steps of cooling to get us down to 7 Kelvin. GH1 as I said, is the TV transmission reception for Telstar. What you can't see on it's quite large. If you walk around it, it's an impressive dish. We have occasionally rock concerts at Goonhilly. We had the Apollo celebration. We also had I won't say celebration to a limited extent of the Virgin Orbiter launch. We did a small celebration for that, but that of course ended rather abruptly when the rocket didn't fire its third stage correctly. Anyway, so we do a lot of outreach at Goonhilly. My other hobby. This is where my semi-professional life comes into it. As I've said, I've been involved since about 1975 with the amateur satellites, particularly funding them in the early days. With AMSAT UK, we have a not insignificant amount of money for the funding and building of satellites. This is some of the ones that I've been involved with. AO73, also known as FunCube, is still alive. It's now 11 years old, almost to its birthday, about 10 days ago. Still transmitting low power telemetry, and as a transponder as well on UHF and VHF. At the same vintage was UCube, which is a satellite, a 3U satellite, developed by the UK Space Agency and Clyde Space in Scotland. It flew one of our payloads as a backup telemetry system. That worked, theirs didn't. Long story. EO79 and EO88, sorry, beg your pardon, EO88 and JO97 look very, very similar to FunCube because they are. Universities in Jordan and the United Arab Emirates went to our provider, which is Icy Space in the Netherlands, to said, have you got a CubeSat that we can use? Well, you don't have something like that. So Icy Space came back to us and said, can we license your design, please? And we spun up two very, very similar satellites. One of them has a camera, which is the extra. Sorry, one has image download, and the other one has active stabilization to a limited extent for this size of satellite. As part of that agreement with Icy Space, we were as we licensed it, we're a not-for-profit organization. It was deemed that they would actually give us the ability to actually have some boards developed and give us free hardware for an upcoming design, but more of that later. UCube-1, as I said, was a UK Space Agency. It went into orbit almost at the same time as AO73. It decayed about 5 years ago. It didn't work particularly well. Some of the experiments on board worked for about a week and then died. But that's the nature of CubeSats. If you don't test it well on the ground, you're liable to fail when you get in the air. The European Student Earth Orbiter was, I think that's almost 6U, but it's not quite the same form factor as was one of our CubeSats. A multi-university satellite. I think with about 16 payloads on board, so it's actually quite ambitious. And we provided the backup telemetry. We always seem to get pulled in when a CubeSat system is being partially built and they haven't thought about the comms. And we need a telemetry downlink. Well, because we've proven ourselves at least 6 times now, we are space rated. We can actually plug our boards into the space of 2 U's, basically. Sorry, the space of 2 pieces of a 1U CubeSat, and we take power from the bus of the main spacecraft. This is a little bit smaller. These dishes are a little bit smaller. The big one, I think, is about 2.5 meters, thereabouts. And there's probably a Starlink lurking around in the background as well. This is the electromagnetic field. As we put it, 2,500 geeks in the field. It happens every 2 years. It's coming up in June next year. And the guys you can see there, the guy on the right, John, it's his dish. The guy in the middle, Phil, he works with me at Goonhilly. And the other guy, Paul, does amateur deep space networks. The big dish was actually pointing at the QO100 satellite, doing some digital TV. So we had to put a big tape around it just in case the public started walking in front of it when we realised what the ERP was. It's a great event. I can't. I'll talk more about it towards the end of the presentation. Going back to what I said about FunCube-1, as a 1U CubeSat, so it's 10 centimeters squared. My colleague Wouter Wegler is actually doing some assembly on it at Icy Space 12 years ago. The image below it is a 3U pack of 1U CubeSats, so they do it stacked one behind the other. If you look on the left-hand side, you'll see there's a spring, and on the right-hand side, you can't see it, it's actually a lid. And what happens in orbit is when the primary, secondary, tertiary payloads have gone off, it leaves the little packs which are wrapped around the adapter ring. And all that happens is the lid opens and the spring pushes these CubeSats out. It could be 1, it could be 2, it could be a 3, it could be a 3U. They just get pushed out. They also launched them from the Kibo equipment on the ISS, but from the ISS they're launched into a retrograde orbit, so they're meant to decay and will never get above the ISS in terms of the orbital maneuver. So there's no likelihood of crashing. Problem we have now is that there's an awful lot of stuff up there, our CubeSats and many others. In terms of the number of amateur satellites, satellites carrying amateur radio payloads, there's now 125 that have been registered. But now there are several thousand Starlink satellites and Azure satellites and Chinese satellites, all doing internet to Earth. And the biggest problem now is that CubeSat FunCube-1 is in the same orbit, but we got there first. That's not an excuse. The problem is that we get conjunctions. You can roughly predict where your satellite's going to be within a sphere of probability, and all the other satellites have that sphere of probability too. So NORAD constantly work out what those intersection spheres are going to happen. So we get conjunction alerts. We get at least 3 conjunction alerts a week, and we know it's going to be a Starlink that we have a prop that's going to be very, very close to us. Our closest probability has been 50 meters, which is somewhat worrying. And we watched it very carefully, and she went through the pass, and she came out the other side. That's the closest. They're normally about 2 kilometers. What normally happens is that we get the conjunction warning, and we get one the following day, and it's disappeared because the Starlink satellite, the ground stations, have maneuvered it out of the way. The trouble is, in maneuvering, they also have to reset all the other satellites in the constellation because that one's moved, particularly if they're using optical comms. So for Starlink, they're dynamically moving their satellites all the time. I also have fun with balloons. My previous employer, B2 Space, their original thoughts were to actually send a balloon up to the stratosphere, 100 kilometers, and then launch a rocket from it. The idea being that you do away with the first and second stages and carry it to altitude, and all you're left with is the third stage. Some of these images are probably about 3 years old now. There's one missing, which was when we launched one of the balloons off the back of a Spanish Navy frigate. And you might ask, why do you do that? Because you can actually keep up with the wind at sea. And so basically the balloon remains vertical just as you launch it. The image third from the left on the top is one of our rocketry tests. That was at a airfield in Wales. What looks like a square block around the side of the rocket basically is the pointing system. If you imagine a rocket dangling from a balloon, it's going to sway about, it's going to swing, it's going to twist. So you need to be able to point the rocket in the right direction. So there's quite some sophisticated maths going on within that little box to compensate for the swing and compensate for the twist. Our pointing accuracy was within about 3 degrees. The idea being that we take it up to Saxiford in the north of Scotland, and launch out towards the north to get polar orbit. One side you've got Iceland, the other side you've got Norway, and you've got to go right down the middle of the slot within about 3 degrees. Otherwise, a lot of agencies get really upset that you haven't gone where you've told them to go. Top right is B2 Space's payload test. The idea being that you can carry test CubeSats or test payloads to 100,000 feet, so they can be cold, and you can test them at temperature, at low pressure, at not quite vacuum, but certainly on the way to not a hard vacuum, a soft vacuum. You can carry your payloads without actually launching them into space. So that's basically what my background is and has been for the past up to now. Let's escape from that one.